To all of you joining me for this video, thank you. I am Mr. Ish. Look at the title of this particular video, Easy Ordinary Differential Equations Designed to Look Hard or Difficult. And why would that be the case? Look what we have over here. We're looking at two particular differential equations, two of them, but they're easy technically, but they're designed to look difficult. Here we have dh over dt equals minus r over v, parentheses h over n plus h. Now, why would one assume this to be a seemingly difficult differential equation? Well, for one reason, you don't see the ordinary variables that you're used to, x's and y's, you just don't see that. And remember, when you're looking at differential equations, which are particularly designed to solve or help solve real life physical, chemical, biological, or engineering phenomenon, you're not going to see x's and y's all the time. You'll see other variables, other letters, and that right there is why something easy looks difficult, because of the lack of familiarity students have with different letters. Now, you have to look at this with an approach of determining what your variables are, because once you've determined your variables, all the other letters are your constants. And always clue in onto your derivative factor. In the derivative factor, I'm saying derivative with respect to h over derivative with respect to t. H and t are my variables. And what are the other letters I see? I see a capital R, I see a V, and then I see an N. Those will be the constants which will come into play. Now, when you're looking at this, you've established this, and that's the best thing you've done. dh over dt is equal to all of this. Now, what are we looking at here in terms of everything? I'm looking at here, there's some variable here which is important, and the constant has been pushed out. The other variable is t. I don't see the t, but the t will come into play later on when we do the integral, because you know if you're doing something like this, integral dt, you know it's going to generate a t and then your constant of integration. So just because you don't see the t, it doesn't mean it's not in there. It's there, but it is hiding. Everything is already separated for you. Keep it separated. If when you're looking at this, think about separation of variables. I want to get the h over here and I want to keep the t over here, and I can do that. This entire parenthesized portion should go on the other side. It'll divide, but it'll flip. You'll end up seeing n plus h over h. That's exactly what you're doing over here, is equal to minus r over v. It's not hard from here. I'm going to write it over here for the space reasons. We're looking at n plus h over h. And I have, with respect to what you're seeing over here, is equal to minus r over v. The separation of variables technique, and now do this. Integrate with respect to dt. Look, right here, the dt's will cancel out. You'll be having here the h variable with its dh, the independent variable. Here you'll have integration with respect to dt, and now it's not hard. Separate this across the positive sign, the plus sign, into its separate items. You're looking at n over h dh plus integral h over h dh is equal to what you're seeing over there, minus r over v integral dt. Exactly what I was saying. Now you're seeing how the h and the t are going to manifest. When you're looking at this, you have a constant over here. You can have n natural log h plus, you'll have an integral of dh, which is just an h, is equal to minus r over v t. The t has come, the variable t has become apparent, plus c. You can easily stop right over here and your question would be done. And in all confidence, your question here would be right. N natural log h plus h is equal to minus r over v, parentheses t plus c. You could have done minus rt over v. It's the same. It's all good. But you see how this question wasn't hard, but it looked hard because it's unfamiliar to us. Again, it's still a first order differential equation. We utilize the separation of variables after we determine what the variables and the constants are or were. And that's how you would proceed with this type of question. This represents the second and the last question, but this one is going to be more difficult than the one we just saw. We're looking at dv or dt is equal to a minus 3v divided by b plus 2t. Again, you don't see x's and y's, and you have to determine what the variables are and what the constants are. What are my variables? Always clue in on this derivative factor, and I'm seeing v and t. Those are my variables. But everything else is going to be a constant. A and b are going to be constants. When I'm looking at this, I'm thinking about a linear differential equation of the first order, because if I take this, it'll look very similar to dy or dx plus py is equal to q. It will look exactly like that, except you don't have the y's and the x's. Take this on the other side, see what you get, dv over dt. And you're taking this on the other side, plus 3v over b plus 2t is equal to a. That right there is your linear differential equation of the first form. That's exactly what it is. It looks just like that. You know, you can look at it as this: dv over dt plus 3 over b plus 2t v is equal to a. Why am I doing it that way? Because I can identify what my p value is. My integration factor will come from there, e integral p dx, but there's no x over here, but it'll be all of this, 3 over b plus 2t dt. That's what it's going to be. Now you have to integrate this. You might as well do a u substitution. If u is equal to this denominator aspect b plus 2t, then du is equal to 2 dt, and dt is equal to du over 2. You bring this into play over here. You will have e exponent 3 over u du over 2. That's exactly what I have. You'll bring the 3 over 2 out, e exponent 3 over 2. You'll have integral of 1 over u du, or du over u, same thing. You'll do e exponent 3 over 2 ln u. I'll bring the c over here. You'll have e exponent 3 over 2 ln u, which was b plus 2t. Now all of this is going to simplify to a condensed integration factor, and we have to determine what all of that is. This 3 over 2 can come over here as an exponent. You're looking at e exponent natural log b plus 2t to the exponent 3 over 2. This right here is my integration factor, but it's not simplified because, as you know, the property y is equal to e to the power of ln x is equal to x. This comes right over here. The e exponent ln goes away. Exactly the same thing happens here. Your integration factor becomes b plus 2t to the power of 3 over 2. That's your integration factor, which will now multiply with everything you see over here. Everything over here is correct, and this is equal to that using properties of logs. I won't prove it to be the case, but you know how it is. Do the proof for this is exactly the same as this. We have applying across, I'm putting it right here, b plus 2t to the power of 3 over 2. That's applying with everything over there. As I was saying, this is a slightly more difficult differential equation to solve. When you apply this, what do you get? You get b plus 2t to the power of 3 over 2 dv over dt. We don't know what these letters mean. They probably mean something important. This multiplies with this, but look, there's a b plus 2t, here's b plus 2t to the power of 3 over 2. This can cancel out with that and bring in a root, b plus 2t to the power of 1 over 2. And then you have a 3, and then v is equal to b plus 2t to the power of 3 over 2a. This has come here from a derivative of a certain factor or factors. And what is that? It's d over dt, exactly this v, and this right here. You'll have v, b plus 2t to the power of 3 over 2. If you do the product rule of this f and g function, you'll get this. Think about it. This will multiply with the derivative of v, which is that dv over dt. This will multiply with this by means of the chain rule. Out of the chain rule, when you do your u substitution, you get a 2 over here. 2 will multiply with the 3 over 2, which is coming out of the power rule. 2 times 3 over 2 is a 3. 3v, and the derivative of this by means of the u substitution is exactly that. So this right here is correct. You can do this on the side by means of the product rule, and you would be verifying this indeed to be true. Is equal to a b plus 2t to the power of 3 over 2. Now what remains? You bring in the integral. I'm bringing the integral over here in dt. Remember, we're not doing separation of variables, we're doing the integration factor technique, which is applied to linear differential equations. This goes out. And now you have to do the integration of this, but you can do the integration of this by a u substitution. This right here is going to stay as is. V parentheses b plus 2t to the power of 3 over 2 is equal to a multiplying with now this out of u substitution. U is equal to b plus 2t, and then du is equal to 2 dt, and dt is equal to du over 2. That's what's going to come through. All of this is a u to the power of 3 over 2, and then you have a du over 2. Now you have to do that. It's nothing more than polynomial integral. This du over 2, I'm removing it because I'm doing it a over 2. Same thing. Let's work on this. When you do a over 2, you'll have u to the 5 over 2 over 5 over 2. N plus 1 divided by n plus 1. This 5 over 2 will flip. When it flips, you'll have a over 2 times 2 over 5 times u to the 5 over 2 plus c. The 2's will cancel out. You'll have a over 5 u to the 5 over 2 plus c. This I will add over here, and then we'll simplify everything down to the best answer. V parentheses b plus 2t to the power of 3 over 2 is equal to a over 5 u, which is now again b plus 2t to the power of 5 over 2 plus c. That's an answer, not the best answer. We have to solve for v. We can solve for v and push the item that's attached to it to the other side. This item will cancel with this partly, and we'll have v over here, but you can write it in a better way. V, whatever it meant with respect to t, is equal to a over 5. b plus 2t to the power of 5 over 2 divided by this is no more different than b plus 2t. That's what it is. 5 over 2 minus 3 over 2 is a 2 over 2, which is to the 1, plus c over b plus 2t to the power of 3 over 2. Again, this can be brought up. The variable v with respect to t is equal to a over 5 b plus 2t in a parentheses plus c b plus 2t to the power of minus 3 over 2. This right here is your function or the equation for which this differential equation is true, and it has been solved for you. Again, I'll repeat it. Variable v with respect to t is equal to a over 5 parentheses b plus 2t plus c parentheses b plus 2t to the power of minus 3 over 2, and it should be right. You could have stopped here if you wanted. You can stop here if you want, but this right here, in my opinion, is a better answer. And that right there brings us to the conclusion of this video. Remember, with these type of questions where you have differential equations but you don't see your typical x and y, focus in on this factor. It will clearly tell you what your variables are. Everything else are your constants. And here the constants were a and b, variables are v and t. And that's it for this video. Thank you. Have a good day.